And a very good afternoon to everybody. We are now live on our IITPSA Special Interest Group in Software Testing webinar. Try and say that 10 times fast. So good afternoon. I see we've got some people already joining the call. Rob Kerridge-Walker, our chairperson of the Special Interest Group. Welcome, Rob. Good to have you with us. He says greetings from a super cold Pretoria. You should try Joey's, brother. It's about 3 degrees colder than there, so you don't know what it's like. But anyway, also I'd like to welcome Dirk Loosen, our guest speaker for this afternoon from IT Ecology. Is that right, Dirk?
That is correct. Thank you.
Yeah, suddenly went blank for a second. Sorry. So Dirk, welcome to you and welcome to all our delegates who are busy joining us. I see the count is rising. Malini Bandi, other members of the SIGIST committee. Awesome to have you guys with us, and to all our other members and any guests, non-members. Johan Stein, our chair of Special Interest Group in Artificial Intelligence and Robotics. Good afternoon to you, Johan. So while we're allowing people to log in quickly, as is my norm, I'll kill time for a second or two or three. I would like to remind everybody, and you've probably heard me say this if you joined any of our webinars over the past month, we are running our annual Johannesburg Centre for Software Engineering / IITPSA Skills Survey, which is the ICT skills survey of note in South Africa. We appeal to all our members and non-members who are ICT practitioners to please participate in the survey. The more participation we have, the greater and more credible the results. And as I say, it really has become a definitive survey. It's been running for 10 years. I think this is the 11th year. When Dirk starts speaking, I will actually post the link to the survey on the webinar chat group. And there are 2 questionnaires. One is for companies, the other is for individuals. If you own or work in a company, and if you are a professional, please answer both. But we'd appreciate that. So enough of the sales pitch. And I see we've also got Saba Rahimi, who's one of our new Gauteng chapter committee members. Welcome, Saba, to you. Mike Snowman, old friend. How are you, Mike? Hope you're all good. So, Dirk, without further ado, I'm going to ask you to introduce yourself. Thank you so much for sparing the time and coming to spend it with the members of IITPSA this afternoon. I'm interested and fascinated to hear about shift left, shift right. I had to ask my software engineer son to explain it to me. No, I'm kidding. But it was all good. So, lovely to have you with us, Dirk, and thanks so much for joining us. Over to you.
Thanks a lot, Tony. First of all, good afternoon, everyone. And thanks for joining this talk on shifting left and right, specifically focused on performance engineering. My name is Dirk Loosen, as Tony mentioned, and I'm the owner and lead consultant at IT Ecology. And it's really a privilege for me to share some insights into what we've gleaned over the years in terms of delivering performance engineering services and how things have really changed quite significantly. Let me just start with the presentation. Okay, somehow this starts at the end, so I'm going to have to find my way to the beginning. Not quite sure why this started at the end. Please give me a moment.
Isn't that like Gartner, Dirk, where they start with a conclusion and then go explain how they got to it?
We can do that.
Yeah, I'm just kidding.
If you prefer that order.
I think it's because you and I glanced at it and we perhaps didn't just restart at the beginning. So blame Tony. I'll take the blame.
Okay. That's okay.
Okay, mate.
All right. So thank you. So just in terms of the agenda today, what I'd like to just work through is having a look at how things have changed significantly just from a development methodology point of view, and we're all very aware of that change, but really I'm trying to build up to why that's changed, how we should be doing performance testing at the end of the day. That's really why I'm just repositioning that. Then I'm going to try and give some kind of definition, because if you look on the web, you won't find a very clear definition as to what is shift left and what is shift right. There are definitions out there, but they're similar by and large to each other and to what we're going to talk about. But you know, when you focus very much on performance, you know, I want to kind of get a definition as to what we do in terms of performance engineering that speaks to shift left and shift right. And then I want to show you a potential implementation of such an approach, and kind of have a look at, what could be done. And it's not, I'm by no means want to say this is the only way one could do it. This is just something we've adopted, and but every implementation at every customer is slightly different as well, depending on also how that customer goes about deploying code, and whether they're in a fully automated DevOps pipeline, or still a more manual start-stop type of pipeline, or maybe in a not as modern code scenario. So yeah, going to have a look at a suggested implementation, but just to give you some ideas as to what could be done, and then what would be the typical outputs that you could actually get if you follow this type of implementation, and what would be the value of those outputs, from such an implementation. And then hopefully we're going to have a little bit of time left for some questions thereafter. Right, so let's have a look at, revisit this idea of, well, our development methodology has significantly changed. We know that, we're well aware of it. It's been a topic of discussion for many, many years, but the reason I'm revisiting this change is to say, how has that actually affected those that are involved in performance testing and or performance engineering? And we're going to also define what those terms really should mean. But if you look at this specific picture, we clearly can see, on the left, obviously waterfall/agile, but even that, from traditional agile to where we find ourselves with automated pipelines in a DevOps style world, things have accelerated significantly. I'm working with customers that are literally pushing code into a dev environment 3 times a day, and the unicorns out there internationally are doing that even faster than that. So that is certainly the way we're moving. How has that affected what we do? Well, certainly, we need to have a look at the results and the consequences of these changes. And of course, the first significant result or consequence is that we've got much faster, or much shorter sprint cycles. In waterfall, we're all aware we had annual, biannual, or quarterly releases. Now we, have, let's say, 2-week sprints. As an example, I mean, your sprint time is your sprint time, but whether it's a month, 2 weeks, 1 week, it doesn't really matter. 2 weeks is sort of a common practice, but at the end of the day, that's not the key here. The key is it's significantly faster. And then, of course, as we adopt DevOps practice and accelerate that even more, we may find ourselves in sort of daily release cycles. And that, of course, brought with it that we've changed the way we release code, because you cannot release 3 months worth of code in a day. So we've obviously broken down this code. That was always the intent, to break the code into more modular, more reusable type of code, where the code is independent of each other and could actually be executed separately. And this independence is what also allows us to test independently some of this code. So from very monolith type code and with very limited reuse, we've got much more modular code today. And then, of course, having much smaller code parts to a bigger application, the application being made up of potentially REST APIs or some other form of modular code, that lends itself then to completely different architectures in terms of infrastructure as well as application architecture. So from typical client-server, web app, database type environments, which typically were single tenanted as well, we've moved to very multi-tenanted, containerized type environments, where a piece of code sits on one container and another piece of code sits on 10 other containers, and so on. And the scaling is way different. Here we had a very static architecture that we would have to scale out when we saw all of the code, could not be sustained. The user base could no longer be sustained on this combined architecture. We then would maybe add one more web server or one more app server, or maybe increase resources on the database server, whatever the case may be. Today, we literally can say, well, this one piece of code is really the one that is getting used a lot more. And that's where we're burning. So, we need more containers for that one, but the rest we can keep the same. So that has changed a lot in the way we need to go about testing. And that's really why I'm positioning this. In terms of the direct ramifications of how our testing has therefore changed or should change, and I'm not talking only about performance, this is literally speaking to testing as a whole. But how we used to do is very much pictured in this inverted pyramid, also called the ice cream cone. I think a lot of you are very aware of it. There's a link here because I've taken this picture from a well-known site where this is, pretty well described. But yeah, at the end of the day, we used to test much later. We used to do elementary unit tests, more integration tests, and then even more automated GUI tests. And a lot of our testing was still very manual. So our UAT tests were certainly primarily manual. And even today, you actually find, and that's why this picture still shows manual session-based testing. But the reality is there is still always a need for some manual testing up at the top. But the pyramid has certainly been inverted. It's absolutely, the focus is now on automated unit tests. And I'm not saying this is how it works everywhere. I'm saying this is how it should work today, okay? Because I'll get to the next slide why this is so important. But yeah, a lot more automated unit tests, then some component testing, because as we spoke, as I mentioned earlier, we now have a more componentized type of architecture, and therefore we can grab a component that's finished and we can start testing it. We don't have to wait until we've got all the components together to do integration testing. Of course, once we want to see them integrated together, that's when we do our integration testing. But we don't have to wait with testing, with doing sort of, the upper layers of testing. We can do some testing earlier to see whether that specific component is actually working. And that could very well be an API with a number of endpoints as a component. So it's no longer just a unit, but it's code that can be tested in its isolation. And then when it's integrated in, let's say, other APIs, then we can go into integration and ultimately automated API tests. That could be a full user journey. And ultimately, the GUI on top could be a mobile test, could be a web test, whatever it might be. All right, so it's significantly changed how we should test. The benefit of this change ultimately is testing some things much earlier. And if you think about why should we test earlier, why shouldn't we wait until everything's done and then we start testing? Well, the reality is, if we did this and we waited as we did before, by the time, because developers now work on very small parts of code and then move on to another part of code, maybe a different function, by the time we've noticed there's something broken and we give it back to development, it may no longer be assigned to the same developer because he's already working on the next function or on another piece of code. I don't want to say he's forgotten what he's done, but if you wait long enough, yes, he will have forgotten what he's done. He's moved on. He's done many other things in the meantime. While his focus is still on actually writing, the code, that is when he should be doing his unit tests. And really, in effect, this is, for many organizations, this is why we do what's called test-driven development. I'll have a slide on that, but yeah, don't want to spend too much time on this because we ultimately want to move towards the performance leg of this, but it is vitally important that we get this type of testing right for the benefit of, testing earlier, getting problems raised with development earlier, so they can be fixed quicker, and ultimately, this is much more is much less maintenance intensive, providing much faster feedback. This also provides a little bit of insight why this inverted pyramid thingy is so bad. Well, the reality is, the reason it's so bad, if you look at this picture on the left, you'll find that if all of these dots are considered methods, all right, method calls, and you'd have the method tree that, of multiple layers that ultimately end up a method calling a database. Then if these were the potential interconnections between methods, the potential of a method calling another method, and then the database, then, and obviously a front end calling the sort of entry method, you would have to do 70 rather complex and pretty fragile end-to-end tests. But if you think about end-to-end testing, UI-based testing in automation, those automation tests are pretty fragile. They're robust. We found ways to make them robust, but they're by no means as robust as unit tests. By a long difference. And they take time. They take a long time to script. All right, these 70 rather complex tests. If you compare that to what you could do, and if you turn this, this pyramid upside down, you would end up doing 61 unit tests, and they're pretty easy and quick to do, and you'd end up with 8 end-to-end tests. So you can see how much less end-to-end tests you'd have to do, and how many more unit tests you'd have to do to get the same coverage, exactly the same coverage. All right, but in terms of actual time, the second option is a whole lot faster. I keep wanting to click on the slide to move forward, forgetting that I have to use a next button. Right, so in terms of shifting left, really what we've already talked about is it comes down to testing a lot earlier. And there are also these concepts around test early, test often, fail fast. And really that's what this talks to. That's what shift left in testing really means. Because if you can fail fast, especially if you can fail fast cleverly, you don't want to run tests that are just going to fail fast and not give you any value. But as the next slide will show, test-driven development really helps there in building tests first, and they will always fail, not just fast, they'll fail immediately because you haven't built the code yet. But that being said, as you then build code to meet that test requirement, you're literally developing towards this working test. So this applies very much to Agile and DevOps environments, where the system becomes available before the whole system is actually considered complete. So you can have certain parts, as I mentioned, REST APIs, or any part of the system can become available to test, rather than having to wait like we did in very monolithic type applications where we literally had to wait. We didn't, there were too many dependencies. And then, of course, in a services architecture, we know that we can work in isolation from the UI. You can have things like, services that have underlying services, nano services, that feed a microservice that feeds a GUI. So you have a UI that makes calls to a microservice. The microservice might make calls to other microservices. Those microservices might make calls to nano services. They may make calls to third-party services and or the database, whatever the architecture may be. But that allows you to really go and test any of those pieces upfront before the rest of those consumers are available. Also, it allows you to split out and say, well, if I've got the GUI available but the services aren't there yet, well, what can I do about that? Can I maybe stub or create service virtualization so that the GUI actually works, or vice versa. GUI isn't built yet, but we can use service virtualization to test various of the endpoints when some of the other endpoints aren't there yet. So endpoint to endpoint, we can, or third-party integrations, we can use service virtualization to help us to actually test the service we built against the service that doesn't exist yet. So there's a number of things we can do to accelerate what will be ready for us to test. And then, of course, as I mentioned, this concept of test-driven development, I'll go into that on another slide, so I'm not gonna spend time here. And I don't actually want to spend too much time because, as I said, we really want to move into the performance side of things. But what is test-driven development? I have mentioned it. It's really sort of build the code, and build the test around your requirements. Get your requirements, write the test against the requirements, then write the code against the test. And we're talking primarily unit test here. This is not the tester's job to build the test that the dev has to meet. This is a unit test, and the developer basically builds his test, then builds the code to meet that requirement or that test until that test then passes. Then he's going to go back and refactor that code to make it work more efficiently, potentially more efficiently in terms of performance, because very often we build very crude code here, to just meet the requirements, to functionally make it work. But then we want to go and refactor to make it work better. And then we take the next part. So there are a number of benefits of test-driven development. We already alluded to many of them, so I'm not going to spend time here. But yeah, that's really something you do need to look at from a dev point of view. Okay, this is not something you're introducing in test. It says test-driven development, but this is a development practice. And if you want to get testing and shift left testing, if you want to get that right, then this is almost a must-have. Because if you're not doing sufficient unit testing, which this basically enforces, if you're not doing that, you're not going to get. You're basically saying you're not getting the buy-in from development teams to assist with bringing out the volumes of unit tests that are required to alleviate higher volumes of functional and UI-based tests, as I've shown in some of the previous slides. So this is quite crucial. All right, then before we jump into how this affects, this sort of change, how that affects performance testing and performance engineering, I want to kind of position how I see the difference between performance testing versus performance engineering. So, of course, our sort of performance testing, and I'm speaking about the traditional term performance testing, how we used to do it. It's very much, forms part of any testing discipline, and we used to evaluate what types of tests, such as load, stress, scalability, and or endurance testing, and we'd find, there are many others, but some people use different terms for those, but yeah, that's sort of the I guess the most used terms in the industry. Those are the types of performance tests types that we would run, and by and large, a lot of organizations run primarily load tests, and here and there that run a stress test and not much else. Already that is a bit of a concern, especially as we move into the future. If we never did scalability testing in the past, you'll see how that thinking of doing scalability testing actually starts becoming something that now has to take place because our scaling mechanism has significantly changed, as we already saw in terms of AI in the first slide. Then in terms of, traditional performance testing, obviously was heavily focused on server-side testing. We would have protocol-based scripts that we'd run. And I mean, a lot of you, whether you, are running, I don't know, load runner, JMeter, we're not here to talk about tools. All I'm saying is, those are the sort of typical things that organizations use. JMeter, Gatling. There's a lot of open source type of tooling, and that's fine, but they're all protocol-based tooling. In other words, you'd make a recording, let's call it, for lack of a better word, a proxy, where the traffic is proxied through and recorded in that fashion. And you'd then go and amend those scripts to look at session IDs and parameterization and correlation, as we used to call it. And that's all important still. All of those things you still need to do today. And then very often and more as we've matured the traditional performance testing discipline, we realized we can no longer just run the test and then the first question when we show the output and it had a spike in the middle of the test, then we'd be asked, but why? And we had no answers to that other than, oh, the CPU was high. But why was the CPU high? Oh, I don't know. That we realized just doesn't fly anymore. So we started to look at what other information can we provide. And that's when application performance management tools came around, and they became stronger and stronger. And I mean, they're really, really strong tools in that space today. So yeah, we've included that more and more in our sort of traditional performance testing over time, and it's become, I almost want to say, it's become a must, because as we've mentioned on the very first slide, as the change towards a very distributed architecture has taken place, it is now so difficult. We can no longer say, oh, it was the CPU, because it's no longer just a server that we're monitoring. It's potentially containers that we're having to monitor. And it's, we need to start understanding the interactions between those containerized, APIs, services, third-party services. So it becomes very difficult to follow a user from, he's clicked on this button and, but it was actually the third-party integration that was slow, or no, it was actually a database call or a specific method call, or it was this specific REST API that was sitting on this container that was slowing things down for him. And it's all possible today, but it depends a lot on the type of tooling. And that is why today I talk a lot about performance engineering, because your traditional performance tester hopefully has matured to a performance engineer that comes along and understands performance completely, first of all, from a life cycle point of view. In other words, we want to write performance into the requirements. We've always had that, or we're supposed to have that, but you often used to look for a requirements document and you would get a functional requirement specification, but never find a non-functional. Here and there, some customers that were more mature, you'd have that, but by and large, over the years, I've seen that was very often something that the business analysts just couldn't come to grips with. How do you ask what it should be? And even if you know how to ask what it should be, business analysts very often don't understand how to ask what it should be under different conditions. In other words, the ramifications of a user sitting on a different line across a different network. These were starting to be technical questions, but they needed to be brought into a requirement specification, and that was always difficult. So today, we really need to get that right, and it doesn't mean we need to have hefty documents, but we need to have a process by which a performance engineer is able to go and ask the right questions to get the relevant that we use quite frequently at our customers, questionnaires that really help us to get to grips with the lay of the land very, very quickly from a performance perspective. So we really want to introduce performance by design. We then want to understand performance and this performance requirement from a number of perspectives. The business perspective needs to be what the user experience is going to be. It doesn't help just load testing a server like we used to do in the past and then find that the user experience is still bad, even though the server turnaround time is really fast. So how do we get that right? That's something we need to maybe unpack a little bit. And in terms of, we call this outcomes driven. In other words, the performance engineering discipline must look at the outcomes, not in terms of, the server is fast, but what does that mean to the end user? Is the user going to have a good experience regardless of what type of network he may be on? Or if he's on a very particular slow network, do we at least understand these are the criteria? He needs to have this type of network, otherwise this will be slow. And we can have that conversation with business and see that that's acceptable. All right, and then in terms of, obviously, the user experience is one part. We still need very much, obviously, all the other parts, meaning everything thereafter. We need to understand when we clicked and it takes a certain amount of time, what was it further down that caused it to take a certain amount of time? And hence we're now combining very heavily any sort of APM tooling, as well as the use of real user monitoring and synthetic monitoring, over production and sort of seeing how does that work in production, but how can we simulate these things in pre-production, where we've traditionally only done, server turnaround time. So how do we get around those type of limitations? All right, let's go and have a look at what shift left kind of means to performance testing, or performance engineering for that matter. And here I just want to mention a little bit about the 80-20 sort of style of traditional performance testing, where we've taken 20% of the transactions because we just couldn't very often take 100% of business process flows and script them. There just was never enough time for that either in most organizations. So we've kind of taken an approach very often in traditional performance testing of saying, well, let's apply an 80-20 rule, where 20% of the most used business processes touch enough of the application. And if we bump up the usage, the volume of users and the number of transactions of those business processes, then we should make up the load that the other 80% of usage that we're basically now ignoring. So that our performance test still simulates sort of a real use of the 100% of users and 100% of sort of transaction volumes. And that's all good and well, but the problem that we have now is, in the past, we would be exercising with that sort of thinking. We'd be exercising the same architecture, the same environment, the same web server, app service, the same database. Well, that's not totally true today in a sort of distributed environment. If we ignoring certain API calls, for example, out of our performance tests, then what we're actually doing is, if we thinking of increasing the load against other API calls, well, then that's not a great idea. Why? Because we're increasing the load artificially, potentially against containers that aren't actually going to run, those APIs that we're trying to increase the load for. So we really have to be careful about how we design our load patterns in this way of thinking. I'm not saying it's all wrong. From a web server, very often you still got web server components if it's a web application, and it might be underpinned by a lot of REST APIs. But the reality is, we really got to think about what is it that we're trying to achieve. Let's not go and just use an 80-20 type of rule, or even 70-30, whatever you used to do. Let's not go and do that without thinking very carefully about which APIs are we not including, and what are we going to do to somehow include them without having them included in the traditional performance test, because we're still going to run this traditional performance test, as you'll see on further slides. Anyway, I just wanted to quickly, get thoughts around, around that specific aspect of where that way of thinking is going to cause us problems. All right, one of the other areas, obviously, it could also cause us to have insufficient coverage if we're ignoring certain services. So are we saying we should now script everything? Probably not, because we still don't have the time. In fact, we have less time in most cases. So what is the approach that we should take? So that is why I'm talking about, shifting left, because we're saying, well, to fix this problem, we do have to test much earlier and test what we can when we have it. So that when it comes to this, let's call it the traditional test that we're going to do much later, then we've already got a lot of coverage done, and we can then focus on the sort of almost a performance integration test, for lack of a better word. All right. So basically, shift left for performance has the same rationale as just general shift left. It's all about greater coverage and failing fast, failing earlier so that it can find the problem earlier, and dev can go and fix what's broken and retest before it gets to the bigger test later. All right, some of the challenges that we have that you don't have with shifting left normal testing or functional testing, but you do certainly have those challenges to try and shift left performance testing. Some of the challenges, well, dev and test environments just aren't the same scale. We've always asked for our own performance test environment, and hopefully we got it for our big performance test. And hopefully it was scaled in many cases as big as production, and that's sort of the utopia world of our performance testers. Doesn't always hold true. Many times we were forced to live with 50% of that environment, and we'd have to make certain assumptions. Well, even there, now we're suggesting you should do some performance testing in dev and test. That's just not going to work, because those environments are much, much smaller. Okay, they just don't scale as well. They're also much more susceptible to other loads. If there's a handful of testers in those environments, and you're going to try and throw some performance test in there, you're either going to affect them or they're going to affect you, depending on who's got the bigger load. So, or both. So, those are definitely challenges we need to talk about. And then, of course, stubs or service virtualization are generally also not built for performance. I recall a specific performance test I was doing at a customer at one of our banks, and I didn't realize in which I was just given the server that was basically a stub for a service that they were building that was included in the performance test. We were doing the performance testing, and it was showing the service call was extremely slow, and they had literally wired up this desktop that was the stub, and they wired up this desktop to my performance test environment. And of course, only when we tried to troubleshoot why it was so slow did we realize, well, that works for dev, but it's just not going to scale for performance. So what are we going to do there? What can we do? And I mean, service virtualization platforms can scale to support performance, but it's just something one has to be aware of, that they need to be set up appropriately then. All right, so ideally, we don't want to run huge loads early because of those constraints. So what we're actually saying is, why don't we run much smaller performance tests much earlier and then grow bigger as more functionality is available or as more of the code can be tested? All right, so such more manageable performance test scenarios might be a single service call. It might be a combination of service calls, typical CRUD, create, read, update, and delete type of functions on a REST API. So you might have one API that's entirely completed. Then you can actually do I don't want to call it a journey because it's not a user journey necessarily, but it certainly is a CRUD journey that you typically want to test the whole API and all its functions. And you could if that's all completed, but you wouldn't then integrate it with other API functions or with the UI or anything like that. So certainly that could be as small as a single service by a single virtual user. And our traditional performance testers are going to pipe up and say, but that's not a performance test. Well, if you are intending to find out how that performs, then it's a performance test. And if you are then going to do the same test again to compare how it performed the second time, then that's a second performance test that you're going to use to compare against the previous performance test. So is that viable? And my answer to that is, oh, yes, and I'll show you why. And of course, it could also be a single journey if it's a UI type test. So then you could break it up if you're developing a certain journey. As I said, generally in this day and age, the environment early on doesn't support journeys, but if it's just a change of a journey, the journey existed, a small change has been made to the actual journey, and you just want to test that journey in isolation to the bigger performance test, then you could obviously try and do that. It's a much smaller test. Again, it can be a single virtual user on that journey, or it can be a number of virtual users. And we'll go and have a look at a possible approach that we've adopted. And as I said, then that the next step could be a multi-user test against a single service, but still keeping the user count quite low. As long as you have an adequate environment, which very often in dev is not the case, in tests, in other words, sort of the integration test environment, SIT, whatever you call your original, your first test environments, those are built potentially a bit bigger than dev, potentially not, but they may be in a position to sustain a little bit of a bigger load, but definitely not very often these sort of big loads that you have in performance testing. Either way, the general idea, again, is test earlier, find the bottlenecks earlier, and find them by isolating the code. Because by testing only this code that you have now isolated, or that you're testing specifically, if something breaks in that code, you're not looking for a needle in a haystack. You are actually, looking at very specific function, and it's so easy for the developer to then go back to that function and rectify it and retest. So what is shift right in performance testing? Well, this is the stuff that I've already talked about in terms of what we call performance engineering, and really comes down to doing a lot more monitoring. What do you do with all this monitoring then, you might ask? Well, first of all, the types of things that we want to monitor is we want to monitor real user experience. Because if you don't know in production what your real user is experiencing, you really, your traditional performance testing that hasn't had real user experience included, and you've then thrown things over the wall, you've probably very often seen a disconnect between what you had out of a performance test and what you eventually saw in production, unless you had included some network testing and some potentially manual tests to understand what the performance of the UI is for the user. But that's why more and more today we find in production there's a lot of sort of application monitoring out there, of real user monitoring. And of course, there's also this concept of synthetic user experience monitoring, and that's useful, especially if you want to see what the performance is at different times of the day, because very often what you might find is users work at certain times of the day, but to warn you that there's suddenly a problem or a bottleneck because some additional capacity hasn't come up, but the user base is growing at 8 o'clock in the morning, well, then your synthetic user experience can start warning you before it gets too bad, and you can then manually intervene and make a plan. Anyway, so those are the sort of monitoring aspects. What they provide you with very often are user journeys. And those are very useful for us as performance testers. Why? Because now we can learn how users are actually using the application. I mean, the way we used to, come up with performance test scripts has often been that we'd look at the training guides, or we'd look at, the specifications we were sent, which claimed that this is how we would want the user to test the application. And sometimes changes are even made, and they're not made in the documentation, and nobody's made aware And these things happen, and suddenly you realize users are no longer using the application the way that they're missing a certain step, but you've got that included in your performance test script. But that step is no longer valid. And so we're finding things out by watching what the real users are doing. More importantly, we're finding out how much of it they're doing. In other words, we came up with a load test scenario that said that 50% of our users are definitely going to do, a transaction rate of X against the, search an item, put it in the shopping cart, and go off to purchase. Go to the cart and make the purchase. And then there may be a different process flow that we're saying, okay, we've planned for, our performance test plan tells us that we've got 20% of the users are going to do that flow, and they're going to do it at a certain transaction rate. And very often those were not thumb sucks. Let's face it, they were, well estimated, and I almost said guesstimated, but they were well estimated calculations that we've gotten from gathering requirements as well as we could. But by the time the application went live, if we don't go out and monitor what users are actually doing and how many transactions are actually being, run at the user level, how many process flows are actually being used of each process flow type, then we're going to find it challenging to amend our performance testing scenarios to appropriate loads, and we may be under or we may be over what real users are actually doing out there. And of course, I'm now talking about user flows. What about loads against REST APIs? How many times is a certain REST API actually called by not a specific user flow, but by all the user flows that make use of that REST API? Okay, we need that type of information so we can see, are our flows in our performance test actually simulating the same load? Why? Because as I said on the very first slide, well, that specific REST API call may well hit certain group of containers that may have a limited pool of resources and number of containers. It may not be set to auto scale and just we can scale ad nauseum because that gets rather costly. So there are things we need to really watch out for here and sort of learn from what real users are doing in production at different times of the week, different times of the month, and how are we better aligning the way we performance test based on that for all the different, and I want to say the term levels of performance testing, and I'm going to introduce those in a moment, as well as tests that are, for example, infrastructure-based tests where we're trying to see how things scale, how different networks actually affect the user experience, and we can see that in production. We can see in production very often through good production monitoring. We can see what type of browsers are used, what mobile devices are used, which ISPs users are coming from, what bandwidth they are coming through, and therefore how all of those metrics actually affect our performance. So a lot of that is visible in our production monitoring tooling today, and it is our job as performance testers to go and get access to this information and to go out and use it very proactively in our performance testing. And that is what we call shift-right performance testing, or performance engineering, is really making use of production data and information, both at the user experience and at the more granular level, and feeding that information, hopefully even in an automated fashion, back into our performance testing. All right. How do we do this when we've got the information? How do we actually then, and this is the second part of shifting right performance testing, because just like we're looking to have this mapping of user journeys and clicks to the actual underlying API calls, third-party integration calls and things like that. Understanding those relationships, how do we get to understand those and simulate those relationships in performance testing? And this is where I want to introduce using user experience testing in performance testing. In other words, why don't we go along and hopefully reuse our functional scripts? All we need to go and do is, in our functional tests, log the actual time that every click is. All right, and then we run the functional tests in parallel. And of course, certain tooling makes that a lot easier, but you know, we're not here to talk about tooling today. We're here about doing this in principle. That is possible. Doesn't matter whether you're using Selenium and Selenium scripts in parallel with, or Appium scripts in, if it's mobile, in parallel with your, let's say, Gatling or JMeter top load test. That is very, very possible. And you can then obviously automate this a lot more in terms of taking those step timings, those click times, and bringing them back into a side-by-side report that then shows, during my performance test, I had certain processes that I included in this user experience. And remember, because of functional testing having a lot higher coverage than what you traditionally did with 80-20 performance test, suddenly we don't have to use high loads against these functional tests, because that's not scalable. That's why we do test at the protocol level with performance testing. But we could do one user each of each and every functional test out there if we want to, okay? And that would give us single user experience of every click, potentially, and would give us certainly a relationship between all the clicks, where we also have the traditional sort of HTTP top protocol tests, and we can then see this relationship between, oh, the user clicked here, it made that specific HTTP call. We can now build a relationship between our server turnaround time and our click time, for lack of a better word. All right, and that way we then also are increasing our load test coverage, because we're running a load test, and I'm still referring here to the later load test, the sort of traditional load test, but we're now starting to run this test, including functional journey tests, so that we're increasing our coverage. And basically, we could be exercising every single pod if we talk about a sort of a Kubernetes or whatever type of containerized environment. We could literally be hitting every pod at least from a single call point of view, and that would help us a lot, at least for those things that aren't used a lot, and therefore we would have excluded them from the traditional testing. But we now have some metrics at least to say we've got them included, we've got some coverage here that hopefully helps us uncover even those that don't sit on the combined infrastructure, as we were experiencing previously in this sort of in monolith applications with a sort of a more a less distributed infrastructure. All right, let's jump into a suggested implementation, and this is by no means the only implementation. This is purely a suggested implementation that we've done for a number of customers, and it's been successful. And basically what we're suggesting is up to 3 levels of performance testing. And what this comes down to is basically the 3 levels being what we call a level 1 or L1 being a very small test, an L2 being a medium-sized test, and L3 being basically our traditional test, plus, as I mentioned just now, our user experience tests in this sort of traditional type of test. Now, what that allows us to do is to basically run much smaller test much earlier, a medium type test earlier, but not as early as the small test, and then a larger test later. You may choose to ignore the medium type test and only run small and large. It entirely depends on your environments, your applications, the speed at which the cadence of your development. It depends on a lot of things. So I'm not going to say this is the only way of doing things. This was done in a pretty high cadence environment, and it was reasonably successful. But you're going to have to tweak this, to what works for you. But I certainly would highly recommend, starting with an L1 type of test, and then see, is that sufficient, or can we then wait until we've got everything together, or is there actually room for an L2 type of test in between? Some common requirements that we have with performance testing anyway, but they are specifically prevalent in smaller tests. As we already said, with dev environments, there's other testers, there's dev and developers in that environment. So the environment has got a smaller scale, and therefore it's busy in the sense that it may well be a problem for use with performance tests. So we need to look for a not so busy time slot. We need to integrate it, ideally integrate into the pipeline, run in relevant environment settings, make sure that the settings stay static. It doesn't help comparing a before a change was made API test to a after a change was made API test. Ideally, monitor all these environments with APM tooling, especially if you can integrate that into a pipeline, such as a Jenkins pipeline. And then ideally, prefix these names so you can easily find what these tests look like when you're reporting them back into an automated pipeline. And I'm gonna jump straight in because I see our time is almost up. So I want to talk a little bit about these tests, what they mean, very briefly. Very short burst tests, okay? Number of iterations though, because there could be differences between running this test once and again. So you'll find that there are some differences there. Here's a suggested sustained period, overall duration, and a pacing time. And then if it was a journey test, we'd set it up like that. This is purely like when I say journey, we're primarily talking about the CRUD type test, where you're testing an API journey rather than stitching APIs together or endpoints together from different APIs. So that's really just a suggestion there. And then of course I don't need to go into the traditional test, but to elaborate on reporting on step times as well as server side timing. All right. What would those outputs then look like if we do this? Well, we'd get something if we've built this into our pipeline, and assuming our pipeline is something like, I don't know, Bamboo or Jenkins or whatever tooling you're using for your pipeline, you could then get this type of report back in Jenkins. And the beauty of having this type of report in Jenkins really is that your developer has access to this. Now, first of all, you'd need to think about who actually is going to build this initial test. If we're building it in dev, is the developer actually going to build this test? And very often the answer in some customers is going to be yes. Developers are quite keen to get involved in this type of thing. You may find that when you start talking about performance ramifications overall and how this approach can really help, developers are not totally against this, and very often quite helpful in constructing these initial API type performance scripts. But yeah, the benefit is ultimately they see it in an environment they're familiar with, and everybody else that's sort of looking at the pipeline is able to get these results directly in Jenkins. This, for example, is a report just looking at response time, but you can have any type of chart in there. And as you can see, you can then chart this type of thing, such as any metric, whether it's response time or any of the other metrics you would traditionally get from a performance test. This is a single API call, and it's described here. There's a lot of description that we've built into the integration, that as we run this, it describes what the test was all about. And it then goes and reports these iterations that we've tested. But this is not for a single test. This is actually now reports against the previous build, and there's your build number. And as you do the next build, it automatically runs the next test and then shows you how things have improved or gotten worse in terms of just this single API. Every time you're checking it in, these tests are done, and you immediately know, are we making things better or making things worse? If there's some fluctuation, it's generally not a problem, and you can then let it through to L2 testing, where we can then see if volume against this type of API change has made a difference. But we can start comparing the before and after, because you can literally build this into run it now, apply the change, do the build, run it again, and you're immediately seeing the difference. Okay, and that's what that would look like. Okay, we have a median, and then we have across our services that we were testing here, and we'd have another report showing for a specific test. This was our min max and our average values for response time in this case. But those charts, I mean, you can build this out to have any sort of metric there, but it's all in Jenkins, and that's really powerful for dev to then be involved, and for operations to be involved, and to look at the same metrics in the same tool, rather than you holding your report in terms of your performance test reports, and one day when you release that to the general public, when you've cleaned it up and put it in a formal Word document and it gets signed off, and then somebody sees the performance test results, it's too late. This is immediate, it's in Jenkins, it's automated, it becomes part of the pipeline, and it's what we call a performance signature. It literally, on the fly, gives you a signature of the performance of that specific API, whether single use by a single virtual user, or by 10 or 20 virtual users, if it's a level 2 test that might be done in a sort of SIT environment. That's, at the end of the day, what you then want to see. In terms of shift right, the output will look something like that, where you're basically reporting the traditional metric of, let's say, navigate to homepage was 3.4 seconds, but that's your, let's say, HTTP response or server turnaround time of that call. But at the click level, meaning at the user experience level, it was actually 6.9 seconds. Okay, so significantly slower. But from there, you could see that all the server times would have really given you great response times in your performance test, and you would have possibly signed that performance test off. But hang on, our click response times of complete details, and login was now 3.1 seconds versus a 300 millisecond, server turnaround time. So our rendering and network time, whatever those components, may be and have included, is still contributing a significant amount of time. And so that's where our focus needs to be in terms of troubleshooting and in terms of reporting back and saying, well, we can't let this go into production. This is not meeting our business criteria of, let's say, 3 seconds, if it's actually 7 seconds to search these items. So that's what that output then will provide you, having, as I mentioned earlier, the functional scripts running side by side with the performance test and providing you that type of feedback. Right, I think we've actually overstayed our welcome here. I would have actually liked to give you more time for questions, but yeah.
It doesn't look like overstay, Dirk, because I see our delegates are hanging on, so that's good to hear. Thank you so much. That was very interesting and clearly highly, what's the word? You know your subject matter very well, and you've done a lot of this. So thank you for sharing those with us. I know we're a little bit over, according to the clock here, which is 4 minutes over, 5 minutes almost. But we do have a couple of questions. So maybe if you could have a quick look at them, please, Dirk. I'll read them to you and to the audience. And see if we can get through them fairly quickly, but it's been really interesting. And as I say, the delegates are hanging on, so that's really good. The first comes from Mr. Rob Kerridge-Walker, who asks, when considering the shift left performance testing, where would these be optimally run in the context of incorporating this into a build for a pipeline?
Well, as I've kind of shown very quickly at the back of this presentation, and I obviously went through the last couple of slides a little faster than I wanted to, but certainly we include this in the pipeline. The very first, the level 1 test is included literally on the build. In other words, the build comes into the pipeline and tests are run, and one of those tests run are then these L1 single virtual user, REST API calls, literally calls to an endpoint to see, what is the performance. And very often it is done in a way that that you're retaining the previous build, as I showed in the Jenkins report. We've still got the previous build as a performance signature, and you're then doing another build, and that test is automatically running, and you're then ending up with a comparison, to the previous build. If that answers the question that Rob had.
I can't answer what answers the question, but it sounds like a good answer, Dirk, so thank you for that. And then we've got one other, and then we'll let the people go, and yourself, of course. So this one it was actually a private question, so the others won't see it on the chat, from Viswanath, who asks, how does shift right discussed today how is it distinguished from traditional performance testing?
So traditional performance testing, we didn't traditionally, obviously there has been, for years now, there's been good monitoring in production, and there's been information that's been available. So that part of shift right, of looking at performance and introducing what we can learn from performance back into our scenarios, I think that's not new. It's been used effectively in some areas. It's even been automated in some areas. In other words, I see with some customers, they found clever ways of actually reporting that out of that sort of tooling and finding automated ways of bringing it back into how you're testing in performance testing, and what is included. There are even ways that some tooling today, and like I said, we're not here to talk about tooling, but some tooling has gotten so clever that it literally knows, some of these tools are AI driven. It literally knows this is the code you're building, and because I understand what change was made to the code, I know which test has to be run. All right, so that's how clever the shift left side of things gets. The shift right I wouldn't say isn't quite there at that level, but it's certainly, there are better ways than manually looking at reports in production and then deciding based on that how you're going to use it, use that information in your pre-production testing. But certainly one of the key things that I talked about in shift right is more about introducing user experience type tests. In other words, your functional tests, to give you a much bigger coverage of tests that you otherwise may have ignored, or journeys, user journeys that you may have ignored. And it is not difficult to actually take all your functional tests that you're going to run anyway, or have run already, and to kind of run single user functional tests. In other words, the positive journeys only, of course, not the whole functional test pack that you don't want to do. But you're basically just taking the scripts that that the functional testers have anyway, and you can have a conversation. You're going to get those scripts, and hopefully they can provide you with just a subset that meets those criteria as what you're looking for those journeys that you want to test, and they must just amend to log the actual response time, and that then gives you those timings. And if you can extract those in a clever way, and hopefully again an automated way out of those logs, and sort of find the transaction, if you obviously planning your transaction naming in those scripts in such a way that they match up with your other journeys, your traditional performance testing journeys, then that goes a long way to then aligning those to a report that then gives you those metrics side by side.
Dirk, thank you so much indeed. I think we need to stop there. We are somewhat over now. We've got 10 minutes over, but still, it's clearly been very well appreciated, judging by the comments. Everybody said they found it very educational, and certainly I have. So thank you so much for sharing with us your vast experience and your knowledge and insights, Dirk. Thank you so much. Thank you to our delegates who have attended this evening. We want to wish you a safe and warm evening going forward. Watch out for Eskom. Apparently they're load shedding at level 2 this evening. We need to hear that on the coldest night of the year. And just a reminder to all our members that we have another webinar on next week from our special interest group in artificial intelligence and robotics on carbon and silicon, the future of humanity in the smart technology era. So we hope to see many of you there. Dirk, to you once again, and for all your preparation time, for spending this hour and a bit with us. To the folk who engaged on the chat group, thank you so much. We'll catch you on the next one. Stay safe, keep warm, have an awesome evening.
Thank you very much for allowing me to give this talk. Really appreciate it.
Thanks, Dirk. Keep well all. Bye now.
Thanks. Bye now.